Standard Lego Pneumatics. Reliable, but choked by design.
The standard Lego Pneumatic switch. Reliable, but restricted. Building the rig. Solid foundation first. Mounting the lung and the reservoir. The power core is live. Before we mess with pressure, we need a perfect zero. First, we crack the seal. The standard housing is fused tight. Measuring the stock intake. Only 1.5 millimeters. Here is our bottleneck. Widening the intake. Precision is key.
The drill did the job, but it's messy. These burrs and rough edges will destroy airflow if we don't clean them up.
Smoothing the interior walls to maximize flow. Next, we carefully trim the internal slider to match the new flow rate. Silicone grease ensures the modified seal glides without friction. Precision fit. Reassembly complete. The difference is visible. Standard 1.5 millimeter restrictions versus the bored out 2.5 millimeter channels. Connecting the modified housing to the test rig. The wider ports mean a tighter hose fit. Compressor engaged. System pressurizing to max capacity. Pressure unstable. The thin walls can't hold the load. The soapy water test confirms our worst fears. Massive leakage along the seam.
Microscope analysis confirms the fatal flaw. Standard plastic is too weak. We need an external exoskeleton.
Two parts mix. Cloudy becomes clear. The chemical bond begins, reinforcing the walls with a self-leveling epoxy shell. A custom, thicker O-ring ensures the new seal can handle the pressure. Epoxy cured. Armor locked. Let's see if it holds. Pressure holding. Zero leaks.
Standard flow? Gone. We are now pushing maximum volume instantly. To test limits, we replace human hands with a high-torque servo. Precision toggling, zero fatigue.
We're hooking it up to a massive custom cylinder carrying 5 pounds of solid steel.
Standard flow versus high flow modification.
Boom! The airflow is now instant. Hour after hour, the reinforced seal holds tight. Zero leaks. Zero fatigue. Maximum flow. Maximum durability. the ultimate pneumatic upgrade.